This is a video on series. Last time we talked about what a sequence is. A sequence is a list of numbers. This time we're going to talk about a series, which is when you take that list of numbers and you add them together. We will be dealing with infinite series, so let's talk about a little bit of notation first. We have this symbol, which is sigma, and in this scenario it means the sum, and that's when you take your a sub n, and we're looking at what the sum of all of those pieces are together. This is my starting point, this is my ending point, so we're going to be plugging in 1, 2, 3, and so on until we get to infinity. If this was actually a number, then we could figure out what the sum of any series is. But because we're going to infinity, we don't actually know when it ends. So all we're really going to be doing is figuring out if something converges or diverges. There are several of these tests that we're going to use to figure out if something does converge or diverge. There are going to be so many that you really need to be familiar with when to use each one. So today we're just going to start with the two easiest tests, and then we're going to work our way up from there over the next couple of weeks. The first test we're going to talk about is the nth term test, and this test only is helpful to figure out if something diverges. It in no way helps you to figure out if something converges. Now, I know you're probably thinking there are only two options, converge or diverge. So if something doesn't diverge, then it must converge, right? Well, the thing with this test is that if you don't get 0, then we're going to say it diverges. However, if you do get 0, we don't know for sure if that's a converge or diverge. That's going to be inconclusive. And that won't make a whole lot of sense right now, but on down the road, I'll do some of these problems that are inconclusive using a different test, and you'll actually see that sometimes when a limit is 0, it actually still diverges. So for this test, all we know is that if the limit does not equal 0, that it diverges. If it's 0, it's inconclusive. If it goes to infinity, that's still going to be a diverge. So what we're going to do is just go through each one of these and take the limit, and we're just going to say if it diverges or if it's inconclusive. If you're doing a problem on a test or homework or anything like that, this test is a super quick test that you can use to kind of rule out some things. A lot of questions will ask which of these converge or which of these diverge, so you'll have like several problems that you need to go through. So this is a really quick test to eliminate some options. But again, if you get 0, it's inconclusive, so you may have to go back and use a different one. All right, and if you want to pause the video right now and just try taking the limit, that's fine. If you want to do a couple and then pause it, totally up to you guys what you want to do. So the first one, when I take the limit, these are growing at the same rate. So I'm going to get 2/3. 2/3 is not equal to 0, so it diverges. It's that simple. The next one, the bottom is growing faster, so this is going to 0, which 0 on this, for this test, doesn't let me know if it converges or diverges, so we're going to put inconclusive. And we'll do problems like this another day, and I'll show you how to actually figure out what the answer is for this problem. But for now, we're just going to say inconclusive. The next one, these are growing at the same rate. They're both 3 to the n. So that would actually, we look at the coefficients in front, that would just be a 1. You had some on Delta Math like this with the sequences. And that would be a diverge because it's not 0. Alright, so that's the idea. That's all we're doing is taking the limit. If it's not equal to 0, then it diverges. I'm going to go ahead and work out the last 3. If you want to try these on your own first, that's totally fine. Feel free to pause whenever you want. The next one, e to the n is growing much quicker, so this would go to infinity, which is still a diverge. This next one is kind of tricky because it all depends on how you think about it, and I guess if you were to have parentheses in this. I think a lot of people would, at first glance, look at this problem and think that the bottom is growing much faster because it's 3n factorial. But that 3n's not in parentheses. Because these are both just n factorial, they're growing at the same rate, we have to look at the coefficient. It's the same thing as a, where these n's are the same, so we looked at the coefficients, 2/3, and we look at 3n, 3 to the n, how those are both the same, so we look at the coefficients. So because n factorial is the same, we're looking at the coefficients, which is 1/3, and that diverges. However, if that 3n was in parentheses, then that would be 3n factorial, and that would be growing faster, so that would go to 0. But that's not what we have here. The last one, I could see that the bottom is growing much faster, e to the n, so that would go to 0, which is, once again, inconclusive. All right, so that's all there is to the nth term test for divergence. You just take the limit. If it's not equal to 0, it diverges. A 0 does not mean that it converges. It means it's inconclusive, and we would have to use a different test. The only other test I'm going to talk about today, another super easy one, we actually talked about this before whenever we did improper integrals going to infinity, so very similar concept. This is the p-series, and all we have to do is look at the power for n, and if that p is greater than 1, it converges. If the p is in between 0 or equal to 1, then it diverges. With this, the only thing that makes it any harder than that is just the algebra. So rewriting a radical into exponential form, or if you have a negative exponent, making it positive. One thing with the p-series is that you do have to have a 1 on top. Now you can manipulate a problem. If you have a number here, then you can pull that out just the same we would with integration. So I'm going to go through these. If at any point you want to pause and try some on your own, that's fine. All we're doing is saying if it converges or diverges. There's no inconclusive for this one. That's only for that first test. All right, so the first one, I'm looking at the p-value, which is 3, and 3 is greater than 1, so it converges. This next one, I have to realize that this is the same thing as n to the 1/2, and 1/2 is in the diverges boundary, so number 2 diverges. The third one, I can rewrite by making it positive and putting it under a 1. But 2/3 still fits in here, so this diverges. This is probably the easiest test that we have that lets you know if something converges or diverges. All right, the next one, I have to do a little bit of algebra because I have n and then the square root of n. So this is n times n to the 1/2. When you multiply, remember you add the exponents. So this is really n to the 3/2, and 3/2 is greater than 1, so that's a converge. The next one Be careful, it is not a p-series because it has an n. It has an n in the numerator as well, and we're not allowed to just pull that out. So if you see something like this, it's not a p-series. We would have to use another test to figure out if this converges or diverges. So that's all we're going to say for now about this one, is that it's not a p-series. There's several tests that you can use to figure out if something converges or diverges. We're not going to go over all of them. Most of them just let you know if something converges or diverges. I will show you one next time that allows you to find a sum. But overall, I think we're looking at about 8 different tests that we're going to do. So it's really important that as we do these each day, that you kind of master that test and that you don't get behind at any point, and that you get familiar with when a certain test should be used. So if you see something really simple like this, just like 1 over n to the something, then that's going to be a good p-series problem. All right, this last one, you can actually just kind of ignore this number because you would pull it out front. And if we look at the bottom, it is greater than 1, so this is a converge. Of course, if I were to actually figure out what the sum is, then that numerator would make a difference. But because it's just a number, I'm only focusing on that p-value. That's all the notes I have for you today. I wanted to leave something easy for you. What I would like for you to do now is go to Khan Academy, and I believe, third time's a charm, I believe I have assigned nth term practice on there and p-series practice. You guys know that when you do Khan, there's only 4 problems in each one. I believe I have assigned each one twice. That is at least what I meant to do. One I have set to be due this morning during this class period. I would like for you to work with your classmates. You should all have the same problems. Make sure you're doing the one first that says that it's due today, the 10th. Do that one together. And then there should be a second one that has shuffled problems. Try those on your own. Of course, there's no limit to how many times you go through those problems. The main idea is that you just know those rules and how to do those tests. And that's it. Next time we'll go over 2 more tests, geometric series and integral test, and then we'll just kind of keep going forward from there. We will have a quiz sometime soon. We're going to do multiple quizzes on this section and multiple tests because it is a lot of material, and so I don't want to wait too long to do an assessment. Email me or text me if you need anything, and I hope that wasn't too bad for y'all, and I'll see you soon.